All right, guys. I'll be covering radians a bit differently than other topics. First, I'm going to teach you how to use and identify them, then let you practice with the app. And finally, once you get the hang of them, watch the second video titled How We Build Radians, where I'll go more in depth on the math behind them. We will be using tau in most of our radian measurements. For now, just assume that tau refers to a full turn. I'll formally define tau and how it's used in the next video. Radians are used to measure angles. Instead of saying a full circle is 360 of something, like we do with degrees, in radians, a full circle is simply 1 tau. This makes calculating rotations very easy. You may already be familiar with radians. If a figure skater lands a triple Lutz, you know they have done 3 full revolutions. Alternatively, in skateboarding, spins are measured in degrees. However, if someone tells you they landed a 900, you probably divide that by 360 to realize that they are saying they did 2.5 turns. All right, guys, spin in your chair 1 full circle. That is 1 tau radians. 2 circles, 2 tau. Half a circle, no longer the randomly chosen 180 degrees, but rather half a tau. Quarter circle, quarter tau. See the simplicity? Let's go through some common angles. In an upcoming lesson, we'll cover a concept called the unit circle. The unit circle has a bunch of common angles on it. 0 degrees, 30 degrees, 45, 60, and so on. These angles might seem a bit random, but if I draw in these missing dashed lines, you will see that the angles are just every 15 degrees. This makes calculating what they are in radians a piece of cake. If you count the slices we've cut the circle into, you'll notice there are 24 total. So the first angle would be 1 slice out of 24, or tau divided by 24. The next angle is 2 slices out of 24, thus 2 tau over 24, which reduces to 1 over 12 tau in radians. 45 degrees is up next. It is 3 slices of the circle, or 3 over 24, which reduces to tau over 8. 60 degrees is 4 slices, so we write 4 tau over 24, or tau over 6. 90 degrees, or 1/4 of a circle, is 6 slices of 24, or tau over 4. Hopefully you now have a basic understanding of how to identify radians. I currently have a beta version of a radians practicer available in the Trig Game app. It will have a much nicer UI in the near future once my UI designer is free again. My apologies if it makes your eyes bleed in the meantime. Make sure you see tau and not pi as your circle constant. You can switch between them in the settings on the homepage if needed. In this example, the line marked is 45 degrees. We know that 90 degrees, the straight up and down, is 1/4 of a circle. Dividing that in half gives me 1/8 for the marked line. Now, I have the angle reducer setting on, so the denominator is locked at 24 in the angle selector, and I need to enter how many sections the marked line has, in this case 3. If you want a bit more of a challenge, you can turn the setting off, but then you'll need to input the reduced fraction answer, which would be 1 over 8 in this case. And as you can see above, the 3 over 24 reduces to 1 over 8. In this next example, in the top right, it informs me that I am to solve for the radian angle, given the highlighted angle on the unit circle. Same type as the previous problem. The angle given is 2 sections past the straight down line. I know each quarter of a circle is 6 sections, so the straight down is 3/4 times 6 slices each, for 18 slices. Then I just add the 2 additional onto it for 20 total. Now, that's just one way to solve this. You could also start at the 24 and count backwards, since we are so close to being a full circle. You'd get 24 minus 4 sections, or 20 total. Or in a pinch, you could simply count all the slices. Now, let's input 20 into the slider and press submit for our next problem. In this final example, it's telling me to solve for the unit circle angle, given radians. I can also tell because the unit circle is allowing me to change the angle, and the angle selector is now locked. I'm given 11 over 12 tau in this case. Now, 1/12 is 2 slices, and 11 out of 12 is just 1/12 short of being a full circle. So I can go backwards 2 slices and hit submit. All right, that's all for now, guys. I'll put the app links below so you can get some practice in. Once you're comfortable, check out the next video for more in-depth explanations on radians. Good luck and see you next time.